Hey Team 6-1, this video is on electricity, and I'm going to talk about electric charges and static electricity. By the end of the video, you should have a better understanding of electricity as demonstrated by the notes in your interactive notebook. You know that you need these 2 pages, so make sure that you have them. You're going to follow along while I'm reading, because that will help you as you put things together in your interactive notebook. So, here we go. Electricity, electric charges, and static electricity. Have you ever heard the saying, opposites attract? When it comes to electricity, it is definitely the truth. Every atom is made up of particles called protons and electrons. Protons have a positive charge. Get it? They both start with P, and so it's easy to remember. Protons have a positive charge, while electrons have a negative charge. Electricity is the interaction between these electric charges, the protons and the electrons. Most atoms, which atoms are the smallest particle in which an element can be divided, contain an equal number of electrons and protons. If they are equal, the charge is neutral. However, an atom can gain or lose electrons. If an atom has more electrons than protons, it has a negative charge. If it has more protons than electrons, it has a positive charge. This is where the opposites attract saying comes into play. According to the law of electric charges, like charges repel. Like charges meaning both positives, they will move away from one another, or both negatives will also move away from one another. But if they're unlike charges, so one positive and one negative, then they attract, or they come together. The attraction or repulsive force between charged objects is called electric force. Depending on the size of the charges and the distance between them, the strength of the electrical force can be stronger or weaker. The greater the charges and the closer they are, the greater the electric force is between the objects. Sometimes these electric charges build up on an object. This is called static electricity. Have you ever rubbed a balloon on your hair and noticed that when you pull the balloon away, your hair stuck to it or stood up? Both the balloon and your hair start out as a neutral charge. When you rub the balloon on your hair, electrons from the atoms that make up your hair get transferred to the balloon. Then your hair becomes positively charged and the balloon becomes negatively charged. Since opposites attract, the balloon and your hair are attracted to one another and stick together. Try it sometime. Over time, the charges that build up will move off the object. When that occurs, electrons flow suddenly, causing static discharge. Have you ever ran around your carpeted house in your socks and then got shocked when you touched a doorknob? That is an example of static discharge, when the charges that have built up move off the object. Lightning is another example of this on a larger scale. Alright, so you're going to cut out the boxes at the top when there is an equal number of protons and electrons in an atom, when there are more protons than electrons in an atom, when there are more electrons than protons in an atom. And those, keep those tabs like on the left hand side there, because that's what you'll glue down. We're going to make some little flips. You need to cut out all those circles individually, so those 6 circles. You need to cut out the word electricity. That's a balloon there underneath the atom, and you want to cut out those. And you can just cut them out in circles. It doesn't have to be exactly on the lines. And then, of course, the writing on the dotted line. Feel free to pause the video so you can get that done. We're going to glue these on pages 60 and 61 of your interactive notebook. And so on page 60, which this is where you will glue the reading. And then you can see the layout of page 61. And I'm going to go ahead and zoom in on that. So the atom, you're going to glue in the upper left-hand corner of page 61, and we're going to label those the electrons, and those would be the negatives. The protons are in the center, and those are going to be the positives. The title, electricity, you can glue at the top, and then your 3 tabs underneath that. Make sure you get them in the correct order, the same order as what I have in here, so that when we go to the next slide and you write underneath them, you're writing the correct spots. Alright, it talked about how opposites attract, but we also read about how like charges repel. So then underneath the atom, you're going to glue 2 negative circles, and in between them, you're going to put arrows going away. That means repel. And the same with 2 positives in the red. You're going to put arrows going away from them. And then last, you'll put a negative and a positive, and that's what attracts. And that leads us to the picture. The balloon, you're going to put some positives and negatives, and then you're going to draw a person with hair. You can draw yourself. And when you rub the balloon, then the negative electrons move from your hair to the balloon, so that's why they're circled. And it's also showing the electrons being transferred. Notice we have all the protons, the positives, still in our hair. And because that is happening, they are attracted to each other, making your hair stand up. Again, feel free to pause the video. Next, underneath that first flap is the the charge is neutral. And in the middle one, it will have a negative charge. And on the far right one, it has a positive charge. Okay. Writing about what we read. Discuss a specific time that you've experienced static electricity. In your discussion, explain how it works. So last week I was walking into my room and I got into my bed and my sheets stuck to my clothes. When I pulled them off, I saw sparks. Charges built up on my clothes and rubbed off on my sheets. When that happened, static discharge occurred. Remember, static discharge is like, I would always say, oh my gosh, you shocked me, or if I touch somebody, hey, you shocked me, or I shocked you, vice versa. So that's what that happens. But static electricity can also be when you are doing the rubbing the balloon on your hair. So feel free to write about a time that happened to you. This will be the final look of your interactive notebook, I hope. Maybe even neater than what you see here. And you're going to take a picture of it and send it to me in Echo. And you know that I want to give Jay Smith credit for creating these pages. Remember, I just create the video for you to listen and follow along because you're good at following directions, right? All right. So don't forget that you are a Red Hawk. And what do Red Hawks do? We say, "Go Red Hawks!" Rah!